So let's do this question. Vector equation of plane pi. Okay, we are going to find the vector equation of plane pi such that point A lies on pi where A is given as 2, 4, and 7. So let's draw the origin point first of all, okay, to visualize this question. So we have the I coordinate, the k coordinate, and the j coordinate. So this is the origin O, okay. So if I draw a plane, let's say this is the plane that we are talking about. Okay, so this is the plane that we are talking about. And they are saying a name, they have given the name pi for this plane. Okay. And they are saying A lies on 2, 4, A lies on pi. So I can say this is A. Okay. And if I connect this, yeah, and if I connect this, so here you can see this is the position vector of a point on A. And I can say that is equals to A. Okay, so we know the vector A or the point on the plane. Okay, so that is given. And they are saying pi is parallel to lines L1 and L2. Okay, so the thing is, when they are saying some line is parallel to a plane, okay, so if they are saying some line is parallel to a plane, what that means is there are two possibilities. Okay, there are two possibilities. Okay, so the line can either be over the plane or under the plane, like this. Okay, it can be over the plane or under the plane. That is one possibility. It can be over or under. Okay, it won't overlap with the plane. It don't intersect the plane. Okay, it's just parallel to the given plane. That's the idea. Okay, that's the given idea. Okay, but there is also another possibility in which the line lies on the plane. Okay, the line lies on the plane. But in this question, they have told us the lines are parallel to the plane. So we can't say it lies on the plane. It is not given. But they are saying it is parallel to the line L1 and L2. So it can be L1 and this can be L2. We don't know. Okay, this can be L1 and this can be L2. What we know is these lines are parallel to the given plane. Okay, that's all we know. Okay, that's all we know. And that's what we are going to use to do this question also. Okay, so let's say this is L1. Okay, let's say this is L1 and let's say this is L2. Okay, so they are parallel to the given plane pi. Okay, so let me write that down. So this is L1 and this is L2. The thing about L1 is that it is made up of a point vector and a direction vector. Okay, we know that. And the direction vector, okay, when we studied about intersection between lines, we learned that the direction of the lines will be used to find the angle between those lines. You should remember that. Okay, similarly, the direction vector of the given line will be parallel to the plane. Okay, if a line is parallel to the given plane, that means the direction vector of the line is parallel to the given plane. Okay, so let's say this is equal to A. Okay, let's say this is equal, well, we can say A because we have already denoted A. So let's say B. Okay, so we can say B is equal to 2, -1, and 3. Okay, and let's say this is D. Okay, so D can be given as 4, -2, and 7. Okay, here B is parallel to pi. At the same time, D is also parallel to pi. That's the idea here. Okay, so the thing is, here we have two direction vectors and a position vector of a point on the plane. So we can come up with the vector equation of the line. So pi can be given as R equals to A plus S B plus T D. Okay, so if you want to make this clearer, you can write this down as R equals to 2, 4, 7 plus S. Yeah, S is a parametric value. It can be any real number. And T is also a parametric value, which can be any value. So S into B is given as 2 -1, 3. Okay, and D is given as 4 -2, 7. So this is how you can come up with the vector equation for a plane by using a point and two parallel lines. Okay, now let's do another practice question. You can do it by yourself if you want to. So in this question, we have to find the plane phi where B lies on the plane, okay, and L1 and L2 are parallel to the given plane. Okay, so this is also easy. First of all, we know these are the direction vectors. Okay, so let's write down the direction vectors. Let's say B can be given as 3, 4, 5, and D can be given as 6, 8, -2. But the thing is, since this is B, okay, instead of vector B, let's use another letter, okay, maybe C, yeah. And B or OB, which is the position vector, which is B, can be given as 5, 2, 9. Now I can come up with the vector equation plane for the plane phi, and it can be given as R equals to B plus SC plus TD, where S is a real number and T is a real number. So I can rewrite this such that R equals to 529 plus S into 345 plus T into 6, 8 and -2. Okay, so here we have to keep one thing in mind. Okay, we have to keep one thing in mind. The thing is, when we were learning about the vector introduction for vector equation of a plane, we knew that these two direction vectors should not be parallel to each other. Okay, we have to keep that in mind. Well, in this question, I shouldn't have used parenthesis. I should have used angular brackets. Okay, fine. So we know these two are not parallel. Okay, C is not parallel to D. Why? To get 6 from 3, we have to multiply it by 2. Well, that's fine. And if you multiply 4 by 2, it will be 8. That's also fine. But if you multiply 5 by 2, you will get 10. But here we have -2. So they are not parallel to each other. This one should be very familiar for you. Okay, because I have introduced that to you why they should not be parallel. Because if they are parallel, this equation, okay, this equation will be an equation for a line, not a plane. So you have to be very careful about that. If you have something like this and they clearly say that x1, y1, z1 is not parallel to x2, y2 and z2, okay, if they say that clearly, okay, you can write the vector equation for pi such that r equals to x naught, y naught, z naught plus s into x1, y1, z1 plus t into x2, y2 and z2. Okay, so this is the general idea. Okay, this is the general idea in these types of questions. You have to keep that in mind when you're doing a question like this. Okay, so this is the basic question that you can face. Okay, that you can face in vector equation for a given line. Okay, given plane. So we'll do some more questions in the next video. Yeah, stay tuned.
Thanks for watching the 28th video in our vector series. If you found these practice questions on the vector equation of a plane helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.